Hey students, in this video I'm going to now continue talking about systems of equations, but we're going to focus on the substitution method. So before doing Algebra 2 level, I want to just quickly review the Algebra 1 level using substitution. So a system is given to you right here, and you're going to look for the easiest equation to start with. You want to first isolate a variable. The second equation looks like the easiest one, so we'll start with that. 3x equals 6. We're going to isolate for x, so divide by 3 both sides. X equals 2. So in the solution, we have a pair of x and y. Now we need to find the y because we already found the x. So we're going to now write the other equation we have, so 3x plus 7y equals 14. And we're going to be substituting where the x is at with the value we found, the 2. So we're going to write 3 parentheses 2 plus 7y equals 14. And now we solve for y. So 3 times 2 is 6. And to get rid of the 6, we're going to subtract 6. Now we have 7y equals 8. And then we want to divide by 7. So 8 divided by 7 is not a whole number, so we want to keep it as a fraction for now. So 8 over 7 is your y value. So this is the solution to the system. And sometimes the solutions are not whole numbers, so it makes you doubt yourself. You can always plug it in and check the values to see if it's true. So once again, all you gotta do is substitute whatever the variables are based on your answer. So that x is a 2, we're gonna put a 2 right there. And then the y is 8 over 7, so we're gonna put 8 over 7 right here. And you can just type that in the calculator or do it by hand, but you're wanting to check if that's gonna give you 14. This does, so that does work for that top equation. And then now you check the second equation. 3 times x, we got a 2. So obviously 3 times 2 is 6. So that also checks. So your goal is to double check your answer by plugging in the values and seeing if it works. Okay, so the next example, this one is going to show you that the second equation is also the one you want to start with because the y is by itself. However, on this one, you're not going to have a value right away. You're going to have an expression. So here we want to have the y by itself. We subtract the 3 on both sides. And we're going to have two different terms. These are not like terms, so you're not going to combine them. So you're going to write them as 3x minus 3. So now this is what I mean about the expression. This whole expression is going to substitute the value for the letter y. So every time you see a letter y, you're going to put that value in there. So we're going to use the next equation, 2x plus 5y equals 19. And again, you identify the y value, which is right here. So that's where we're going to substitute the expression of 3x minus 3. Everything else, you're going to copy down. But this expression, you're going to have to work with it, distribute and all that stuff. So we're going to have 2x plus 5 parentheses 3x minus 3 equals 19. And then now notice that we just have x's. So our goal is to solve for x. 2x stays by itself. 5 needs to be distributed into the parentheses. So 5 times 3x, that gives you positive 15x. And 5 times negative 3, it's negative 15. Before you start moving things around, you want to combine like terms. In this case, these two are like terms. So 2x plus 15x, that's 17x minus 15 equals 19. So we're pretty close to solving for x. I'm going to go ahead and just continue working over here because of space. So now we get rid of the 15 by adding 15 using inverse operations. And then now we have 17x equals 34. To solve for x, we need to divide both sides by 17, and that will give you x equals 2. And this seems like a lot of work, and it makes you think you're done. However, keep in mind that the solution, again, is an x and y value, and so far we only have the x. So now we gotta pick an original equation and substitute that value in for the equation and then solve for the other one we don't have yet, which is the y. So we're gonna start with, I guess, the second equation. So let's do y plus 3 equals 3x, but again, it doesn't matter which equation you pick as long as you're solving for y. And then we already have the value for x, so we're going to plug in that 2 in there based on our answer. So we have y plus 3 equals 3 times 2, y plus 3 equals 6, and then obviously 3 plus 3 is 6, but you can always do the math behind it by subtracting 3, and then y equals 3. So 3 is your y value for the solution. Again, this is only algebra 1. So pause, rewind, whatever you need to do to review these skills because you're going to need them next. So in algebra 2, we have the example here that shows you 3 different ways that you're going to see systems of equations with 3 equations and 3 variables. These are pretty much asking you how efficient is the substitution method, because sometimes there are other methods that are more efficient. So what do you notice? You notice that the first system has 3 variables on the top, 2 variables on the middle, and then 1 variable on that last equation for this left side. In the middle, we have 3 variables, 2 variables, and then 2 variables. And then the last one has 3 variables on all of them. So how efficient is the substitution method in these examples? Well, on the left side, 100% efficient, because this is already set up for you to easily find one variable by using the first equation. Once you have the z value, now you're going to plug it in right here, and you're going to solve for y. So using the z value, you can find y. And then after that, you're going to have z and y. So now using z and y, you can find x. So this is easily set up for you to find those values right away, 100%. The middle one is set up for you to use also substitution. However, here you're going to have to go back to algebra 1 for a little bit and visualize yourself in algebra 1 using these 2 equations, because these are a 2x2 system. So this, if you use the skills that we previously reviewed on this slide, it can help you find x and y right away. So using that x and y that you found using those skills from algebra 1, now you can plug in on the equation that has 3 variables, and then you can find z. So substitution method can be used as well in this scenario. The last one has a 3x3. So this one, I mean, it's doable to use substitution method, but the most efficient, it's probably not. So I will say no, use other methods. There are other methods for you to be able to solve for this. So it's not so efficient. All right, so next I'm gonna just give you some examples, and then you're gonna be practicing on your paper. So I'm gonna show you the example on the left side, and you will be practicing on your own the one on the right side. So for example, on this first one, we're going to once again ask ourselves which equation is the easiest one to start with. In this case, the last one is, so we're gonna do 2z equals 8, divide by 2 on both sides, and then that will give you z equals 4. So for the solution here, it's going to be an x, y, and z form. We already have z, so we're going to leave that 4. Next, we have which equation should we use next to find another variable. So the second equation is the one we want to use next because you already have z, so you can just substitute it z in this section right here, and then solve for y. So y plus 2, and then for z, we're going to put that 4 that we found. And I'll just color coordinate it for you so you don't get confused. This 4 is the one you found already. And now we solve for y. So we do 2 times 4, and that will give us 8. Y plus 8 equals 6. We subtract 8 from both sides, and we have y equals negative 2. So now we have negative 2 as a y. So therefore, now we use the last equation, and we solve for x. So we're going to do 2x minus y plus 5z equals 24. And we're going to substitute the y and the z with the values that we have. So we're going to use a 4 for the z, and then we're going to use a negative 2 for the y. And everything else we copy down. So 2x minus parentheses plus 5 parentheses equals 24. And now notice that only x is there. So our goal is to solve for x. We're going to use PEMDAS to simplify. So we're going to notice that these two multiply, and we're going to get a positive 2. And then these two multiply, and we're going to get a positive 20. So 2x plus 2 plus 20 equals 24. And then now we combine like terms. So we're going to have 2x plus 22 equals 24. Subtract 22. And now we have 2x equals 2. So to finalize, we divide both sides by 2, and x will equal 1. So that will be the solution for this first example. So make sure you pause the video and try the example on the right side. Okay, the next example, it's similar to the first one. So looking at the 3 equations in the system, you ask yourself which one's the easiest to start with. And now we have the first one being the easiest to start with. So we're going to do 4x equals 32. And we're going to divide both sides by, 32. We're going to divide both sides by 4. And that will give you x equals 8. So on the solution for this, we're going to have x, y, and z, and x is 8. So now which other equation should we continue using? If you look at the second one has the x, so we're just going to use that one to solve for y. So 2x plus 3y equals 10. Substitute the x with the 8 that you just found. So let me switch colors. There you go. And we're going to have 2 times 8 plus 3y equals 10. 2 times 8 is 16. 16 plus 3y equals 10. And our goal is to solve for y. So we subtract the 16 on both sides. And that should give us 3y equals negative 6. And then now we divide by 3. And now we have negative 2 as our y value. So negative 2 is the y value right here. And yes, it seems like a lot of work, but keep going. The last equation is x plus y minus 2z equals 22. And again, we already have x and y. So we're going to go ahead and substitute those values. X is 8 and y is negative 2. And we're going to just copy everything else down. And we solve for z. 8 plus negative 2, that's technically saying 8 minus 2. So that's going to give you 6. And then you have minus 2z equals 22. Minus 6 on both sides, and you end up with negative 2z equals 16. And then now you divide by negative 2 on both sides, and z equals negative 8. Okay, so now again, you can always pause the video, check your answers, but this should work. So now try the practice. All right, last example. Let's go ahead and now look at the equations and notice that the top one has 3 variables. second one has 2 variables, and the third one has 2 variables. So this is what I mentioned earlier, that you're going to have to zoom into the world of Algebra 1 and use these 2 equations to solve for x and y first. And then you're going to use those x and y values for your solution for the system of 3 equations. So let's go ahead and solve that. We're going to pick an equation between these two that has the easiest one to isolate first. So that's the third one. So we're going to use that and isolate the y. So we're going to move the 3x, so add 3x on both sides. And you can leave it in that order of 6 plus 3x. Remember, they do not combine because both of them do not have x's. This one doesn't really need to emphasize mx plus b. It's just pretty much the expression of 6 plus 3x, replacing the letter y. So anytime you see a y, you're going to replace 6 plus 3x. All right, so then now you still focused on that Algebra 1 level, you're going to use the second equation. So 7x minus 3y equals negative 14. And that y is right there. So we're going to substitute that with the 6 plus 3x. And keep in mind that that's just you substituting what y represents. So 7x minus 3, parentheses, 6 plus 3x equals negative 14. And all we have is x now, so we're going to go ahead and solve for x. So 7x, this negative 3 that you see is going to have to be distributed inside. So negative 3 times 6, that's negative 18. And negative 3 times positive 3x, that's negative 9x. And then that's negative 14 over here. So next is combine like terms. Combine like terms is you looking at these as 3 different terms and asking yourself which ones are like terms. So obviously the x's are like terms, and we're going to combine 7x minus 9x. 7 minus 9, that's negative 2, and that's x, the x term. Then we put minus 18 on the side, and then negative 14 on this side. And we're solving for x, so next we add 18 on both sides to cancel that. And we're left with negative 2x equals positive 4. And then divide by negative 2 on both sides. And x equals negative 2. So far we know that x is negative 2. Next, we're going to still use those 2 equations and pick one of those to solve for y. The third one seems to be the easiest because it already has the y by itself. So we're going to do negative 3x plus y equals 6. We're going to go ahead and substitute the x because that's the one we just calculated with negative 2. And everything else you copy down. So negative 3, parentheses, negative 2 plus y equals 6. And notice that we just have the letter y here, the variable, to solve for that. So we simplify. Negative 3 times negative 2, that's positive 6. And then positive 6 plus y equals 6. So definitely that's 0, but we can always double check by doing the math. So minus 6 on both sides, and y equals 0. And last but not least, we use that x and y to find the z. So we're going to do x plus 3y minus 4z equals negative 34. We're going to substitute the x and the y. For x is negative 2, for y is a 0, and then minus 4z equals negative 34. 0 obviously cancels by multiplying times 3, so that's gone. And then now you have negative 2 minus 4z equals negative 34. To solve for z, you need to get rid of this negative 2, so positive 2 on both sides. And that's going to be negative 4z equals negative 32. Divide by negative 4 on both sides. And negative divided by negative is positive. 32 divided by 4 is 8. So z is 8. And that's the solution for this system. So now you try on the practice sample. Hopefully this video helps. Let me know.